Welcome to another lab. Here we'll be dealing with searching for SUID and SGID files. Special file permissions in Linux can be a security risk if not carefully managed. Now in this lab, we want for files with the SUID and SGID bit set, which is critical for security audits. Now, the concepts behind SUID, that is set user ID and set group ID, bits are special permission flags that change how executables are run. Now with SUID, when an executable with SUID is run, it runs with the file owner's permissions, not the person that is running it. Now the classical example is with the pass WD, which needs root privileges to modify the etc/shadow, but must be runnable by all users. Now down to the SGID, similarly, it executes files with group permissions. Now the issue here is if an attacker finds a poorly written SUID root program, they may be able to exploit it to gain root access. Knowing that SUID files exist on your system and monitoring for new ones, it's very essential when it comes to security. Now in order to do this, we shall begin by searching the entire file system for files with the SUID or SGID set and save to a particular file. In order to do this, we'll run the sudo find using the find command to search through. Now the particular type we'll be looking for is files with the permissions for the SUID or SGID. 6000. Now we will be sending these files to be recorded in another file. Okay, we had a typo here. Okay, it's searching through. Now we should know that the /6000 is the perm which matches any file with bit 4000 which stands for SUID, or 2000 which stands for SGID set. The -ls flag now gives detailed output including permissions and ownerships of those files. It will take a while to run since it's searching throughout the entire system starting from the root. Now once this is done, we have to create a test SUID file. Now we switch to another user account and we create a dummy file. So I don't have a user that we could make use of, so we just go ahead to create a user. Let's say let's add a full user with full permissions, say Tata. Now with a password. Now we don't really need to fill these details, but we just go ahead. Okay, now once this is done, we switch to that user and create the dummy file with the SUID set. Now we are in the user Tata, so we will move on to create a dummy file. We'll just call it dummy.txt. Oh, sorry. Let's use the touch command. Dummy.txt. Now we will change the permissions for that file to give it the 4755. Now once this is done, we check out the permissions for that particular file. Now we see the clear permissions that this file has, and this S here shows that it has a set bit as the owner. Now we will exit this user. We are back to our Kali user. Now we go for a second scan of the entire system, and we store it in a new file, say file 2. We store the results in this file. So this will take a bit of a while. Okay, this is done. Now we'll move on to compare the two files. The first file we created, and the second file for which our results were stored in. For the second scan of the system.